So I am a little late to the party with the actual video showing the ways that you can make your phone last the most long-term amount of time, like for years. But I'm going to go over some of the technical reasons that these batteries go out in these phones, whether it's LG or a $1,000 iPhone. Um, and it's going to be useful because I know that you guys are spending quite a good bit of money on some of these newer phones, and you don't want to have a lower battery life within 6 months to a year. And I know that you can buy these battery packs in the cases with the batteries built in, but let's face it, there are some things that you guys need to know. Whether it's a Samsung that you're scared is going to explode, or an iPhone, or whatever. Even old phones, this applies. Anything with lithium rechargeable batteries, this is going to be very, very important. Laptops included, but mainly phones, because we carry them with us the most. And we don't have access to the plug-ins in the wall all the time, like you would a laptop. You're usually in the house or something. So, that being said, the first thing you need to know is heat. Heat is a huge, huge contributor to damaging lithium batteries over time. There is a reason that your laptop has cooling fans, not just for the CPU, and there's a reason that Tesla and a lot of these newer electric cars have liquid battery cooling systems built in, because without them, the batteries, every single time that battery gets hot, especially while charging or discharging, it lowers the longevity of the battery and its ability to hold a charge every single time. So, that being said, these phones nowadays are running so much processing speed, so much power through the processors, that you're creating a massive amount of heat in both ends of the phone, not just the CPU, but also the battery pack, because the discharge rate. So, because the phone's doing a lot of work, and these CPUs in these phones are equivalent to laptops nowadays. My laptop, I need a new laptop, but it does what I need it to do. It does really good. It's a Samsung. It's got 8 gigs of RAM and a slow processor by today's standards. My phone has a quad core. It may be an 8 core. I'm not actually sure if it's got an octa-core, but it's got a 2 gig, 2.6, something like that, quad core at least, processor, and my laptop is running a 1.6 dual core AMD. So, but yet that processor still creates enough heat to necessitate a heat sink that big and a cooling fan. Okay, so your processing power on these new chips is insane, but you have it contained in a phone that's got no cooling vents or a fan or liquid cool. There's literally no cooling system set up. Then you put the phone in a protective case which seals the heat in. Okay, and then you've got all these other apps running in the background a lot of times, that and using data and doing all this stuff that are not only draining the battery constantly, and you're constantly battling it with the charger, but it's also creating more and more heat within the phone where it would run cooler if there's a way to cut these processes down. Okay? But we're still on the topic of heat. I'll get on that later. But for now, this is the heat is all being produced by the charging, the background apps, and everything running in your phone case. Okay? So, there are a couple of ways to try to counter it. But using these turbochargers and lightning chargers and all that, there's a reason your phone's getting so hot. And if there's a way to keep your phone as cool as possible, if you're charging these phones from very, very low, like near dead, using the turbochargers or quick chargers, then you need to do it because, like I said, when they get hot, turbocharging or lightning charging, whatever you want to call it, they're damaging the battery. And it may be fine for now, but each time you do that, it's lowering the battery life. Not just short term, because it'll hold a charge worse and worse each time you do that. Over a span of time, it'll snowball. But also, it's damaging, you're cutting weeks off of how long the phone will last in the long run. Now, like I said a second ago, when you use your phone up until it's dead, you're actually damaging the battery also. There's a reason that your phones cut off immediately when they get low. They don't get dim, they don't get weaker, they just cut off. My drill does that. It's a 20-volt lithium. My blower uses the same batteries. They just cut off. That's it. The reason is because they're programmed, once they hit a certain reserve amount, they'll go ahead and turn off, because if they go lower, it'll actually damage the battery. A lot of people don't know this. You're actually not supposed to run lithium batteries all the way dead, if at all possible. They don't have a memory. People, for some reason, think that they have a memory and you're supposed to run them all the way dead before you charge them, and that's not true. These were old NiCad batteries, but not these. They actually damage lithium batteries. If you can throw them on a charger whenever possible, especially these turbochargers, the turbochargers are set up with the Qualcomm chips to charge at a higher voltage and higher charge rate until they hit 50%, and then they back off and charge a hair slower, which is a little better on the battery. And then once they hit 75 or so, they back off a little more and round just to top it off. So if you're only running the battery down so far before you hit the charger and you keep it topped off, it's actually exponentially better for the battery than running it dead and then just slamming it with voltage all at once. What if we did that when we ate? Waited till we were starving to death and just gorged. We'd probably be in the bathroom puking our guts up. These batteries are the same way. So when you run it all the way dead, not only is it going to charge at a super high rate and produce a lot of heat, they're going to have to do it for even longer before the thing can get full and cool off. So definitely you don't want to do that. Don't use a turbocharger unless you're just in a bind. If it's dead, if you're going to bed and the phone's dead, hook it on a regular phone charger, like a slower phone charger, like an older one. And it's going to be sitting there for 6 hours. So go ahead and throw it on a little 2 amp charger or something, or 1 amp or whatever, and let it, trickle charge. Same with car batteries. If you're not using it, you put it on a trickle charger. You don't throw it on a 50 amp or 100 amp charger and then leave it all night. That's just stupid. And the slow charges cover the surface area of the metal plates more consistently, so you end up with a better charge. In other words, fast charging it, you may get 50% battery power in 10 minutes, but it's going to act like it only gained 5% because it's going to crash back down just as badly as it did going up, generally, especially if you've been doing this for 6 months to a year and you've already started to deplete the battery quality. Let's see. The amperage on the chargers I need to cover. The way these turbochargers work is you can only put so much amperage through a USB cable and through these USB ports, so you're limited. Even with newer batteries and newer technologies or whatever, you're limited to what amperage you can push through them. So what Qualcomm did is design chargers and chipsets that can accept 3 different voltages. You could push higher voltage through, just not the amperage, right? So, and there's always a trade-off, or there can be an exchange and a trade-off, just like a transformer. Transformer can take a 1 amp, 120, 10 volt wall plug and turn it into a 40 amp, 12 volt or whatever, and vice versa. So there's a trade, right? Amperage for voltage. So what Qualcomm's doing is these new chargers have 3 set voltages. 5 volts like a regular USB, which is what your battery in your phone charges on generally, okay? And 9 volts at a lower amperage, and 12 volts at an even lower amperage. So that the USB cable, the port, everything can handle it. If it pushed through, 3 amps at 12 volts, it'd probably blow up. But anyway, what it does, the charger gets the 12 volts, 1 amp, when your phone's dead, into the phone. Then the chipset reads it and sees that it's turbocharging, which is why there's a longer delay. It waits, figures it out, and then does the exchange with the transformers and the chipset. It turns that into really high amperage of 5 volts to charge the battery. Because, you can't put 12 volts into a 3.5 volt or 3.7 volt battery. It would explode. Like putting 100 volts on a car battery. So that exchange happens, and you've got your higher amperage going through, and it charges really fast at the correct voltage. But with that exchange, there's also a lot of heat produced. A lot. Not just from the battery being charged, but the transformers themselves produce a lot of heat. And they're not really like big transformers. They're transistors like. So these little boogers are getting hot, like the inside of a computer case or something. And there again, as I said before, no ventilation, no cooling fan, no liquid cooling, and you got a phone case on it. This sucker is getting super hot, okay? Especially if it's at step 3, pulling 12 volts into the phone and then transforming it and charging your phone up from dead or whatever. So tips you can do: try not to run your phone dead, okay? Secondly, if you're stationary or you're on a long trip in the car and you accidentally ran it dead and you're using a turbocharger, pop the case loose if you can. Like the skins, a lot of them, they're easy to pop the corners and stretch off, and let the thing air out, and that'll help a lot. In my other video, I said a lot of these vent clip mounts and dash mounts are in front of the air conditioner vent. That's awesome if it's summer, because your air conditioner vent can also help cool the phone.